So I think we should be live. Let me just quickly check the stream. If some of you are there, can you type in yes if I am audible, if I'm actually live? Okay, hi Vishnu. Great. So I think people will start joining. Yeah. So we'll take up today's problem. Let me just quickly go ahead and put a reminder in groups that we are live. Okay. Hi Ashutosh. Okay. So yeah, I think we will start joining. So it has been a good week, I would say, on Leetcode. Like a lot of harder problems, I would say, compared to a general week, right? Even today's problem is considered hard, although it's slightly easier compared to the past week ones. Yes, but yeah. So Ashutosh is saying one request. You can mention it in the chat. We'll see what can be done. Excel sheet containing all the questions shared that week. Okay, we'll try that. Actually, they are all of Leetcode, so Leetcode already maintains it. That is why we did not do it. So Leetcode has a daily challenge, right? So it's just from there. Yeah, this was an easier problem than a medium problem. I would disagree. Like the concept of it is slightly tricky, and especially it being an interactive problem, it creates a lot of other issues. So yeah, so no worries if you were able to solve. If you were not able to solve, we'll try to tackle it from scratch. But this one is a common interview problem. Like a lot of companies I have seen do ask this particular problem, right? Okay, so I think we can start diving into the problem. So the problem goes like this. It says that let's say we are given something known as a mountain array. Okay, and then they have defined a mountain array. So for mountain array they have said that first thing important is the length of the array should be more than or equal to 3. That means there are at least going to be 3 elements in the array. Second condition that is given is that there exists some I such that array of 0 is less than array of 1 is less than array of minus 1 array I. So basically there will exist any one I which is greater than 0 such that the array is completely increasing till that point. So as an example, if I if I try to portray it in form of an example, it could be something like that. Okay, let's say we start with 2, next element should be more than 2, so let's say 4. The next element should also be more than 4, so let's say 7, and then let's say it goes to 11. So a portion of the array in the beginning starting with 0th index, every next element should be more than the previous. Also, because it is given that I till where it is increasing is more than 0, there would at least be 2 such elements. So for example, if I create an array like just this, it is not valid because there should be at least 2 elements that are in increasing order in the beginning. Does this make sense that this array is not valid according to the question? Can I get a yes if this makes sense? That why this particular array is not valid as per the question? Because question says there must exist an index I such that, and that I should be greater than 0 such that every element from 0th index to that index should be in increasing order. There should at least be 2 elements in the beginning where the array is increasing. Does this idea make sense? That why the second kind of array is not allowed? Because there are not two elements which are increasing. Just type in a quick yes if this makes sense. That why this kind of array is not allowed? Because the first condition becomes invalid. 137 is allowed. Yeah, based on right now the conditions that are given, it is allowed. But there is one more condition. Let's look at that. Second condition says there also exists some I till length minus 1, less than length minus 1, such that from that I till end the array is decreasing. So again the same thing, there should be at least two which are in decreasing order. So for example, if I create something like this, it first increases. So this is basically your I. So everything from 0 to I should increase, and then from I till end should decrease. Oh, I think I'm not sharing whiteboard, so I'll go back to whiteboard. So I will be your this element 11 in this case. So everything till I from the start should be increasing, and then it should be decreasing, right? And this I cannot be at the extremes. So we are not allowed to take just decreasing or just increasing array as per the question. Does the array constraint make sense from the question? So we are given an array which is a mountain array, which means it must contain one non-empty portion which is increasing, followed by one non-empty portion which is decreasing. A quick yes, then we can go ahead and move on to the solutioning part. So those who are present, if this makes sense, then you can type in a yes. We have not completed the question. This is the array given in the question. We'll read the remaining portion of the question. Okay. So next it says that let's say this kind of an array is given to you, which is a mountain array. You need to find the minimum index of a given element. So you need to essentially search a particular element in the target and find its minimum element or minimum position. So for example, if I ask you to search 7 here, can you tell me what the minimum index would be? What would be the answer for this particular question? If I ask you to search 7 here, 2. Does everyone agree? 2. So 0, 1, 2. There is another 7 at 5, but we are not taking that. So minimum index which contains 7. Okay. Which is second index starting from 0. Answer one more question. Can our array look something like this? 2, 4, 7, 7, 11, 9, 3. Can this be our array? Yes or no? Reading the question. Is this a possible array or not? Possible. Okay. What do others think? Is this kind of an array possible? 2, 4, 7, 7, 11, 9, 3? No, right? It is not possible because the question clearly mentions what it mentions: array of 1 strictly greater than array of 0. Like it's strictly not less than equal to or not greater than equal to. So when it's increasing, it should increase strictly. When it's decreasing, it should decrease strictly. The only case where the elements can appear is if they occur one time while increasing and one time while decreasing. Does this make sense? That on one side of the array there cannot be duplicates? Yes or no? If this much is clear to everyone, we can think about solutioning. Okay. So given a mountain array, find the element. Help me out. What could be the absolute simplest solution to this? What would be the simplest solution to this particular problem? Linear search. Okay. How many of you agree to this linear search? Like, what can we do? We can simply compare with each of the elements. So what I'll do is, let's say, if this is my given array, let me just remove a few other things. Right. If this is my given array, what I can do, and let's say I want to find 7, I can start comparing from the beginning. That is my first element 7. Answer is no. Second element 7. Answer is no. Third element 7. Answer is yes. So I get this particular index. Does this brute force idea make sense? Just a simple loop from the start till you find that element. Yes or no? Okay. What is the complexity of this? What is the complexity of this? O of n. O of n. What could be the worst case? The element is not there. Or let's say the element is at the end. So you need to search for every place and then you will arrive at a conclusion that there is element is not there. Right? So O of n in worst case, time wise, space we did not take any extra. So O of 1. Okay. Tell me one thing. Did this question actually use the nature of the array? Mountain array nature. Was it a solution for that specific array or was it a generic solution? Like it could work in any array. Can I say it was a generic solution? Like it could work in any array? Yes or no? Our solution of simple linear search works in any array, right? Okay. So a lot of time this will again be a common pattern that you come up with a brute force and then for the optimization you would need to look at the special conditions given in the question, right? What are the special conditions given in the question and that I have not taken into consideration while coming up with the solution, right? Okay. So to take into consideration this special condition, what do you think? What could be the ideas? Can we use binary search? Okay. What do you think? Can we use binary search? As two parts are there. Very good. So do you agree that if I just had this much portion of the array, I could have used binary search to find the element? Just the increasing portion of the array, I could have used binary search. Do you agree? Yes or no? Because it's a sorted array, and to search an element in a sorted array, we are told that binary search is there. Just find the mid, then see if you want to search on left or right. Right? Similarly, if we actually look at just the end portion of the array, it is decreasing in nature. So again here if we look at it, we could have applied binary search. But the problem is that they are combined. Yes or no? अगर array सिर्फ increasing होता or the array would have been only decreasing, one of the two, then it would not have been a problem at all. We could have simply used binary search. But here, if we look at it, it's like a combination. So how do you tackle that? Can we treat it as two different ones? What do you think? Can we do that? Can we treat it like two different ones? How? How can we treat it like we can find the peak? Yes, very good. So now the next logical step from it would be that, okay, if I had these separately, I could have done binary search. So what if I try to make them separate? How can I make it separate? Simply by finding this peak somehow and getting two parts of my array. Does this logic make sense? And how did we arrive at it also makes sense? Yes or no? That if we have our peak, we are sure what is the peak? Like it increases, reaches a point, right? And then it decreases. Our I, which was the point where the direction of the array changed. So if I know this peak, I can divide my array into two parts. One part which is only increasing, one part which is solely decreasing, and then apply binary search on both. Yes or no? Okay. Now the next question is, how do we find peak? How can we find peak? Anyone who can think of a way to find peak? Binary search again? Okay, but how? Binary search from peak to start, start to peak. But how do you know where the peak is? Okay, okay. So I'll explain a concept that I commonly talk about while discussing binary search, which is the concept of separating condition. Okay. So for that, what I'll do, I'll take a slightly different problem. Okay. So let's say I have an array which goes like this. So let's say there are some zeros, then there are some ones, then there are some twos. Okay. Or let me just make it a little bit more different. Let's say there are some zeros, there are some ones, and there are some minus ones. Okay. And what I want you to do is, I want you to find the first one in the array. Okay. First one I want you to find. Now, first of all, just think, can this be done via binary search? Can this be done via binary search? There are some zeros, there are some ones, there are some minus ones, right? Can we find the first occurrence of 1 using binary search? Is the array sorted first of all? Generally, we are told this, right? The array should be sorted for binary search to work. Yes or no? Okay. Sort karke. If we sort it, then what will happen? All the minus 1 will come first. Then your position will not be right. Do you agree? है Okay. The important concept that comes here is something known as a separating condition. So what is the idea of separating condition? I say whatever our answer is, if we are able to find a condition, some condition which is different on the left side of the answer and right side of the answer, Then we can apply binary search. Why? Binary search में क्या होता है? I find a mid, which is a random element. Then I have to decide whether I should search on left or I should search on right. Yes or no? This is the fundamental concept of binary search. You land at a mid and then you find whether you want to search on left or right. So if at any particular position I know, if I at any particular position I know whether I am on the left side of the answer or the right side of the answer, my job will be done. Yes or no? So let's say I find a mid. उस मिड पे -1 आता है और 1 comes. Can I not be sure that the first one will be on the left side? Yes or no? If I land at a random mid, किसी mid पे L+R/2 किया, mid निकाला. If I check the value at mid, if it's -1 or 1, any of the two, then I can be sure that either this is the answer or something on the left would be the answer. Yes or no? Like right side is useless. Why? Because first one will obviously be on the left side, depending upon how the question is. Similarly, if I land at a random mid where the value is 0, then that means the first one is on the right side. अभी तक वो आया नहीं है. Yes or no? Is this idea of separating condition making sense? That if you know that कोई एक property starting से चलती हुई आ रही थी, then you get your answer and then that property changes. If this kind of thing is there, then when you land at any particular place, you can be sure whether your answer is on the left side or on the right side, and you can use binary search. Is this idea making sense कि separating condition क्या होती है and how it helps in binary search? Everyone? Yes, no? Okay. एक बार help me figure out what is the separating condition in our particular question. हमारे क्वेश्चन में सेपरेटिंग कंडीशन क्या है? What separates peaks left side and peaks right side? Peak is our answer in a way, right? What is it that separates left side of the answer and right side of the answer? Increasing and decreasing. Yes or no? That left side of the answer is in increasing form. That is, an element would be less than the next element. Whereas on the right side of the answer, it's in decreasing form. That is, an element would be more than the next element. Yes or no? So if I simply say, if at some random mid, my array of mid is more than my array of mid plus 1. What do you think? Which side am I on of the peak? If an element is more than the next element, which side of the peak am I on? Am I on the left side of the peak or am I on the right side of the peak? Right side of the peak. Whereas if it's the other way around, array of mid is less than array of mid plus 1, then I am on the left side of the peak. ये समझ में आ रहा है क्या? The main idea. Less में left side. Okay? अच्छा. If I am on the right side of the peak, then I would update my right pointer. If I am on the left side of the peak, I'll update my left pointer. Right? Yeah. Okay. So if I try to divide the solutioning, so there will be one binary search to first find the peak, right? One binary search to find the peak. Then two more binary search to find the element on the left and the right half. Does this make sense? That with three binary search we'll be able to solve the problem. Yes or no? Everyone? Okay. So let me go to the submission that I had made. Let me just log in to my account instead. Give me just one quick moment to shift to my particular account. Okay. Meanwhile, you guys can try implementing it. Would be not a very difficult implementation per se. One more thing is left, which is the problem side. It's an interactive problem. So what do we mean by interactive problem? That I'll also inform. Okay. Why Leetcode says hard? Uh, yeah, it's slightly hard. It's difficult to come up with the solution on your own for the first time. That is why it's hard. Uh, yeah. So why is it an interactive problem? So the question says you need to call a get function of my mountain array, get function of my mountain array, right? And that will give you what is the value at some kth index, right? So when you do mountain array dot get k, it gives you the kth index value, right? And it says you should not be making more than 100 calls to this get function. So for example, when you do linear search, let's say an array has size 500. So what you will do, you will pick the first element, make a call, get me 0th element, get me first element, get me second element. So in worst case, you'll be making 500 calls. That you are not allowed to do. So here the size of the array is 10 to the power 4. So even if there are 10 to the power 4 elements, you are just allowed to get some 100 elements randomly from the array and figure out your answer. Does this make sense? So it's interactive in the sense that you call get, you get that value, and then you figure out whether you want to go towards left or right. Does the idea make sense? Why it is called as an interactive problem? A quick yes would be helpful. I don't have any submission here. Is it? Okay. Any solutions that attempt to circumvent the judge will result in disqualification means. Uh, so there are ways where you can try to, in a way, interact with the judge. Like, so in a way, you are interacting with the judge to get a particular element, right? So if you give some nonsense input, you might try to hack it or something. Although it's not possible, but there is a chance, right? Okay. So let's probably code it out. So first I'll write the brief idea around it, how we'll work around it, and then I'll complete the common functions that are there, right? So what I'll first do is, let's say I'll get the length of the array. So for that, it says that we have a function known as length. There is no restriction on how many times you want to call this length. That is perfectly fine. There is only restriction on this get function, right? First thing that we would want is we would like to know where the peak is. So let's say I find the peak using a function known as find peak. Okay. And now one thing. The peak of your array, can it be at the beginning or the end of the array? What do you think? The peak that we have, is it possible that it's at the beginning of the array, that is at this 2, or at the end of this array, that is 3? What do you think? No, right? Because there has to be an increasing part and has to be a decreasing part, right? So that was important because of this idea. Okay. So the peak should always be between 1 and length minus 2 of the array. Yes or no? Does this make sense? Why 1 and n minus 2? We'll complete this function, but I'm just writing a signature for now. That in this mountain array, find the peak from 1 to n minus 2. 1 is the starting index, n minus 2 is the ending index, between which there will be peak. Yes or no? Okay. Now, first, when I get the peak, first I need to search between 0 and peak, that if I find my target there. So what I'll do, I'll say int, let's say possibility 1 is to find the value from 0 to peak in this mountain array and for this particular target. So if I find the element and position 1 is not equal to -1, I can directly return it, because on the left side only, if I'm able to get an answer, then that is the answer directly. I don't need to search on the right side. Otherwise, what I'll do is I'll search on the right side as well. So I'll again do the same thing. Int position 2 equal to find the value reverse. It's decreasing, so a different function from peak to n minus 1 in this mountain array and with this target. And if position 2 is also not equal to -1, return position 2. And finally we can return -1 if we didn't find it on both sides. Is this overall signature making sense? We can complete the individual functions, but this is the overall idea of the problem. First you find the peak, search on the left side of the peak. If you get an answer, return the answer directly. Otherwise, reverse array, decreasing array, again you try to find on the right side from peak till the last. If you find an answer, return it. If you don't find it on both sides, then you return -1. Is this overall structure of the code making sense? Yes or no? Then we'll need to write the 3 functions, but that is how the structure will be. Yes or no? Everyone? We can directly return if peak is target. If you want to add that, you can add that. So you can say if mountain array dot get peak is equal to target, return peak. Perfectly fine. Okay. Yeah, Shankar. This is very similar to that problem, like very similar or same as that problem, right? This is today's Leetcode challenge, and it essentially is same as the problem that you are mentioning. Okay. Finding an element in a mountain array. That is what the problem is. Okay, is this making sense to everyone? Can I get a quick yes? Then we can move on. Look at the find peak function, and then I would leave it to you to complete the remaining 2 functions. Can I get a yes if this makes sense? The idea so far? Okay. Great. Let's try to complete this find peak function. So what I'll do, I'll create a find peak, and it needs to have an L, it needs to have an R, it needs to also have a mountain array. So what is the type? This is the type. Copy and paste. Okay, so we need to complete this find peak function. How does binary search work? While L less than R, find the mid, L plus R minus L by 2. Then if we are on the increasing side, so if mid is smaller than mid plus 1, then mid or below that cannot be our peak. It would either be mid plus 1 or ahead from it, right? So I'll say if my mountain array dot get mid is smaller than mountain array dot get mid plus 1, then I need to shift my L to mid plus 1. मिड तक तो आंसर नहीं है, मिड से बड़े एलिमेंट्स हैं, तो मिड इज डेफिनेटली नॉट द पीक, सो आई नीड टू सर्च टुवर्ड्स द राइट साइड ऑफ द मिड. Otherwise, if mid's value is smaller than mid plus 1, that means we are on the decreasing side of things. So mid plus 1 से आगे बेकार है, mid हो सकता है आंसर, but mid plus 1 ahead from it is useless. So what I can do is I can change R to mid here. Does this make sense? That if you are on the increasing side, mid is less than mid plus 1, so mid and everything below that is useless. If you are on the decreasing side, so mid is more than mid plus 1, so mid plus 1 and everything after that is useless. But mid could be your peak, right? Mid peak हो सकता है because उससे next वाला उससे छोटा है. Okay, right? So at the end of the day, whichever single element is left in your array, that is your answer. So what I can do is I can return L from here. After reduction, the single element that we get, that is our answer. Does this code make sense? How we are finding the peak? Find a mid, check whether you are on increasing side or decreasing side, and move the pointers according to that. Okay? Is this making sense to everyone? Okay. In a very similar fashion, very similar fashion, we can complete the remaining two functions. One is to find an element in increasing array, another is to find an element in decreasing array. So I think I would leave that up to you guys. Let's instead talk about time complexity. What do you think? What is the time complexity of our find peak? How much time is it taking? The find peak part. Login. Okay. Similarly, can I say the two searches on the left and right part, that will also be login? Yes or no? Login में peak मिल गई, एक side search login, second side search also login. So in worst also it's 3 times login, which is still going to be within the range of log of n. So time wise, if I talk about it, the entire code is also going to be O of log n. Okay, and space wise we are not taking any extra space. So overall, if we think, time wise it is going to be log n, and space wise it is going to be O of 1. Yeah. So that was the idea of this particular problem, right? So if we even look at the size of the array and try to find log of it, so log of 10 to the power 4, 3, 4. So if I just quickly search it, it is going to be not this log 2 10 to the power 4. It's going to be 13 or 14 we can take. So even if we take 14 into 3, that is going to be 42, and we are good within our 100 calls, right? Even if it's twice, it is still going to be within 100. Okay, so yeah, so maximum calls will be 42 into 2, because we are making two calls if you look at it in each find, get mid and get mid plus 1. So into 2, that is still going to be within 100. Does that make sense? They have also mentioned some caching approach in tutorial I just glimpsed. So caching approach is very very simple. So if you are accessing a particular element, right? Let's say element at position X. Then later if you want to again access X, you can probably keep it in a map and don't make the useless calls, right? Because we are doing three different searches, there is a chance that in one search the same element is fetched again in another search, right? So to avoid that, you can keep a sort of map or an array, but that again will take an extra space with you. Okay, does all the ideas make sense here, how we are solving this particular problem? Okay, perfect. So code कर लेना यार सब लोग. I would advise everyone to code it out. It's a good enough problem, right? So yeah, I think tomorrow we'll meet for another problem. The attendance is slightly declined in these live sessions, so we might also ask in the groups, like if you guys would want some simpler level problems, since the problems are getting a little tougher. We'll see if we can do something parallelly for uh, for other people's as well. So yeah, great. Tomorrow we are also having a live webinar where we'll be building our own chat application. So if you have not like registered so far, you can go ahead and do it, right? Yeah, yeah, this question was not very hard, I would say. Simpler than the last 2 3 days, the problems that were coming, right? Great. Okay everyone, good night, see you tomorrow. Bye bye. Stack, I don't think stack, what stack, this problem I don't think has stack. Might have misunderstood, but okay. Tomorrow's session tech, huh? So we are building a chat application using WebSocket. So I think the link was shared in the groups, so you can check that out. Okay, okay everyone, bye bye, good night. Thank you Vishnu, bye.
ठीक है ना। फिर राउंड रॉबिन हो गया, ये प्रीएम्प्टिव होता है हमेशा, इसका एक टाइम स्लाइस देते हैं। ठीक है, राउंड रॉबिन में कोई चीज बताओ, राउंड रॉबिन में हमेशा जो ऑर्डर पहले होता है, जैसे P1 P2
ओ ऐसा
P3
है।